So yeah, the first thing I want to talk about here in terms of documentation is SOLIDWORks MBD. And MBD is really a new, in general in the industry, it's a new initiative really stemming from aerospace and defense industries for the idea of defining all your product manufacturing information or your dimensions and tolerances, which we sometimes shorten as PMI, defining all that just strictly on the CAD file rather than making a 2D drawing at all. So it's a product for SOLIDWORks that allows you to do that, allows you to use DimExpert to place all those dimensions on the model and orchestrate them into 3D views that we'll see here. And the primary outputs you can generate would be a 3D PDF. So a PDF you can open up with Adobe Reader and spin the model around and interrogate the dimensions. And also a new format called Step 242. So we had a question earlier on could we export PMI to a step file. And Step 242 is kind of emerging as the new industry standard for neutral file formats that also support PMI. So the answer is with MBD, yes, we can export PMI on a step file in Step 242 format. And basically we're working towards a future where if you need to send a file to the machine shop or an outside vendor, you're only going to have to send that one step file because it's already going to have all the dimensions and everything else built onto it. So you won't have to do a drawing and a file anymore. So look out for that in the industry. Step 242 is going to become more and more common. And I just wanted to give a quick look at what MBD looks like inside the software and then what the output looks like. So within the software here, I can have a whole bunch of DimExpert dimensions loaded up. If it looks kind of cluttered, they have this nice dynamic annotation view that makes it so just when you rotate to that particular view, those dimensions show up. Okay, and it also aids you with tolerancing too. It'll show us previews of tolerances that are yet to be defined potentially. One of the great things about ASME code now is it allows a global surface tolerance. So if you ever wanted to just put a global tolerance on there, I can say, just profile of a surface to the CAD model, and then, hey, all of a sudden everything's fully defined, right? Fully tolerance. So it'd be nice if you could do that for all your parts, but now things like that are supported in MBD, and it's a nice tool to aid in dimensioning. So to get the output to a 3D PDF, we use this 3D view manager down here, which basically enables you to create kind of similar to your 2D drawing views, and they can include things like sections and things like that. And if you go to export to a 3D PDF in 2018, you'll see you have many more templates available. So they're continuing to enhance this. This is what the 3D PDF output looks like. Basically, it's just a screen where we can rotate the model and access those different views. And the great thing about this is it's going to reduce interpretation errors because if you click on any of these dimensions, it's going to highlight for you the datums and the references that that dimension is between. So things that you just could never get on a 2D drawing there by getting the context of these dimensions. So that's some of the new things there for 2018. And also with MBD, it's now allowing us to also import those files into SOLIDWORKS with PMI. So you will notice if you have MBD loaded up, there's many new file types that when we go to open them, like Step 242, we'll have an option to also bring the PMI into SOLIDWORKS if you need it for reference. So this is really something for the future. I understand most people won't be able to jump to model-based definition today. Drawings are still a really big part of what we do. So Dayne's actually going to be talking about some new synergy between these 3D views and drawings if you still need to produce 2D documentation. So go ahead and switch off to Dayne here.
So drawings have had many enhancements in 2018. The first being that you can leverage that 3D PMI in 2 dimensions with the ability to import 3D annotation views. So some standards require that your tables be in all caps, and now you can make that happen with one mouse click with the all new, all uppercase button, which is available for all your tables in your drawings, part, and assembly files. The whole callout tool is now compatible with the advanced hole feature. You can generate broken out section views on alternate position and detailed views. And you can automatically randomize the hatching scale to further improve the clarity of your documentation. So let's see what that looks like inside of SOLIDWORKS. So Ryan did all the hard work here, tolerancing this component here. And I'm going to take all the credit by putting it into a drawing. So right in my view palette here, I have the option to grab these 3D views, and I can come in and I can grab my DimExpert annotations and any of my 3D view annotations, and I can just drag and drop that in here, and now it looks like I did all the work, so I can take all of the credit for that. So I have my bill of materials over here, and I'm using my 3D interconnect to import a bunch of different file sets from vendors, and it's pulling in their custom properties, but they're not in all caps. And my standard is that I need all of my tables in all caps. So right up here, I have this all uppercase button. One click, it shoots my whole table into all caps. And I can turn that off. It's not going to make everything all lowercase if I turn it off. It'll just bring it back to however it was defined when it was generated. So my hole callout tool will now support that advanced hole feature. And just like that, that would be a pretty time-consuming dimension to generate. I can reverse that callout order if I want to, and of course add any extra text to that as well. So on my final drawing sheet here, I have this alternate position view, but I want to make a broken out section to try and fit as much detail as I can in one small area. So now I have the ability to do that. So I can make myself a broken out section of this alternate position view. So I have this section view here, and I'm going to give myself a broken out section of this section view. So I'll grab my broken out section, grab my sketch in here, and I'm going to randomize my hatching scale. So I'm having different depths of cut inside this section view, and with this nice little radio button here, I can randomize my hatching scale just to show me my different depths of cut. So I have a lot more clarity inside of all these drawings. So now that I have fully documented this design, I'm going to pass it back over to Ryan here, and he's going to show us how we can actually manufacture these parts now.